Do you have one of these things? Everybody has at some point, and I use mine pretty regularly. The problem is, as I grow older, I have a harder time seeing what's going on the dial. I prefer radio equipment that is backlit. I find it very irritating when a manufacturer fails to backlight buttons. That said, this thing's $20. It would have been really easy for the manufacturer to put a light inside of this thing. They didn't. And again, $20. I decided that I was going to add a light to this so I can see what's going on when I use it. And I want to just preface this by saying I use this meter very generally. It's just to get sort of the idea of what's going on. I'm measuring general SWR, general power, but if I want really good readings, I'd prefer a digital meter that can tell me with a decimal point what's happening. What's nice about this is you can leave it in line, and if something goes terribly wrong with your SWR, it should be pretty obvious that something's wrong. However, if it's not lit, I can very easily not notice that something's terribly wrong. And so I believe it should light up. Now, because I believe that I should be able to see it when something goes terribly wrong with the SWR, there's no point installing a battery and a switch to turn the light on, because the light would always have to be on. What I want to know is something goes wrong. I want this to light up. That's my first indication something is not right, and I can instantly see the dial and it will tell me what's happening. Again, because this is $20, I wasn't very worried about breaking it. So what I've done for about 3 pennies is I've installed a roughly 420 to 450 ohm resistor and a simple LED. I tried a few colors. I ended up with green. I will get to the details on that momentarily. Let's just take a look at what we're dealing with here. Okay, I was lazy. This is an AI generated image because I didn't feel like going back downstairs, pulling the parts out, taking a picture of them just to show you what an LED and a resistor looks like. We're going to say 420 ohm resistor, even though that may not be labeled correctly. And I wanted to show the 2 types of LED. The reason is a lot of people are probably not aware of mini LEDs. The larger LED is a standard LED that you find in almost anything. And there are smaller versions that are about 1/3 the size, and they take approximately 1/3 the amount of energy to use. The reason I would use the smaller LED is because it would take less power, and because the smaller LED needs less power, I would want to use a larger resistor. Maybe I'd go up to a 1K to make sure that I don't overload the LED. I probably should have used a 1K anyhow, but what I grabbed was the 420, and it's fine. But if I crank up the power, get up to 60 watts, the resistor starts to smoke, and I don't want to burn this thing out. This project is good for up to 10 watts. We're going to say CB levels of power, 4 watts, maybe 10 watts. If you want to go higher than that, you're going to have to increase the resistance. So remember, the more power you put into the LED, the more it's going to sap RF energy from the meter, making it less accurate. The smaller the LED you use and the higher the resistor, the less energy you're going to steal from the actual power and SWR. This setup, I lose 1 tick worth of energy. I can't even see that at a seated distance, so it works just fine. But to optimize the circuit, you'll want to use the smallest LED that draws the least amount of energy that's usable, and the highest resistance that will still allow you to get enough light. That way, you draw less energy from the system by minimizing the amount of power you're sapping from it. The meter will stay more accurate that way. You can certainly get it to the point where you would not be able to even see the difference, even under close scrutiny, if you get the resistance right. Different color LEDs take different amounts of energy, and so the red LED uses the least amount of energy. So I want to sap the least amount of RF from the circuit as I can. And so the LED that I ended up with, which is green, is not the most efficient LED, not as efficient as red, but it's also not as power hungry as a white LED. I probably, in retrospect, would do this with a mini white. Just look better, I think. But the green's really easy to see. It's a little hard to see in the picture, but the resistor is going into the long end of the LED, positive end of the LED, and the blue wire is coming out the other side of the LED. Now, of course, none of the metal parts are touching. The end of the resistor is soldered to the center pin of the incoming coax. And next to that, there's a common grounding point, which is the outside of the coax, the shield, and the other end, the grounded end, just goes into that, and that just forms a loop. You probably want to use some tape to keep those pots that you see up top there free of the actual metal exposed there on the resistor, or just build a better circuit than I did. In my view, I don't see that obnoxiously bright bulb. It just doesn't look that way for me, but on camera it's picking up all that ultraviolet light that's coming out of there. There you go. That's the easy 3-cent modification you can do to your SWR meter. I do recommend that you play around with resistor values, and again, try to get the smallest LED that's useful, draw the least amount of power from the system. So have fun with that.